Okay, what we're looking at today are reference angles, and what a reference angle is just the angle that gets you quickly to the x-axis. And what I mean by that is, say I have an angle here in quadrant 1, so something in here. What's the quickest way to get to the x-axis? Continuing to go forward to get it here, or going backwards to get it here? Well, it's going backwards. That's why whatever my angle is here in the first quadrant, my reference angle would just be the exact same amount. That's why the theta, my angle, and the reference angle is the exact same. If I'm in quadrant 2, though, it's quicker to go forward to get down to it than go backwards all this way to get an obtuse angle. What we should realize here is there's two things that's always going to happen. A reference angle is always going to be a positive angle, and it's always going to be an acute angle. I can never get negative, and I can never get something over 90. So what's going to happen here is if I need to go forward, that means I need to get up to 180. So it means that my angle to this point, and then whatever added on, needs to get me to 180. Or if I want to do 180 minus theta to get the reference angle, that works as well. In quadrant 3, same idea. It's quicker to go backwards to get to the x-axis than to go forward. So I needed to get to where I was, but I need to go backwards. So I need to take off whatever it is to get me to 180. Taking off is my reference angle. So I get r equals theta minus 180 if you like your formulas. And the last one, if you're in the fourth quadrant, I just need to continue up a little bit more to get to 2 pi. So how much more do I need to add on to get to 2 pi or to get to 360 degrees? And again, depending on what you're in. If you're in radian mode, instead of saying 180, you're going to be saying pi in these instances here. And for 360, you'll be saying 2 pi. So it depends on what mode you're in, radians or degrees. So let's find a few of them. Reference angle. What quadrant first is theta in all these? That's what we should be checking first. So 108 is in quadrant 2. 271, quadrant 4. Negative 148, I should try to rewrite that first by adding 360. And I should get that this angle is going to be 212 degrees, which would put it in quadrant 3. Remember, adding 360 to add another time around the circle. 2 pi is not as much as a pi, but more than half of it, so that's quadrant 2. Pi over 8 is in quadrant 1, and 11 pi over 6, just shy of 2 pi, would be in quadrant 4. Now that we know what quadrant we're in, now we can figure out what our reference angles have to be. Because we're in quadrant 2, we should be going forward. How much more does it take to get to 180? That's what I should be figuring out. So my reference angle there is how much more to get to 180. So it's really like saying 180 minus 108, which gives me 72 degrees. That's how much more that I need. If I'm in quadrant 4 like I am in number 2, I need to be pushing forward. How much more do I need to get to now 360 degrees? So that's going to be my 89 degrees is how much more to make this add up to 180, or I'm sorry, to 360. And number 3, 212 degrees. In quadrant 3, that means I need to go backwards. How much do I need to take away to get to this amount, 180? How much do I take away? It would be 32 degrees in this case. Now, when I do my radians, nothing changes. I'm still here in quadrant 2. I still need to go forward to get to pi in this case. So my answer for this one, how much more does it take to make that a pi, a full pi? I would need an extra 1/3 of a pi, an extra pi over 3. For number 5, in the first quadrant, well, if I go up this much, I got to go back down the exact same amount. So anytime you're in quadrant 1, the reference angle is the exact same as the angle was to begin with. And here in number 6, if I'm over here, how much more does it take to get to 2 pi? That would be just really simply, I just need to add another pi over 6. That'll get me 12 pi over 6, which simplifies to 2 pi. All right, here are 4 more. Give them a try and see if you can find the quadrant and the reference angle. Go ahead and pause the video and restart when you're ready. All right, the biggest issue that you're going to have here is getting the quadrant, especially for this first one. Here's what I'm going to look at. You know it's more than a pi, so it's definitely either quadrant 3 or 4. 1 pi, if I made a common denominator, would be 5 pi over 5. 2 pi would be 10 pi over 5. Which is this closer to? 8, is it closer to 10 or 5? It's definitely closer to 10. That means this has to be in quadrant 4. Same here. This is more than a pi. Excuse me, so it's going to be 3 or 4 again. Well, is it close to the 71 pi over 71 or close to the 142 pi over 71? Definitely closer to the 71 pi, definitely closer to just 1 pi, so quadrant 3. Same with the angles. I think you're pretty good with the angles. This is quadrant 2, and this one here is quadrant 3. So, as we remembered, when we're in quadrant 4, we need to say how much more do we add to get to 2 pi, to get to 10 pi over 5. I need my numerator to be 2 pi more, so 2 pi over 5. For this one, in quadrant 3, I need to go backwards. I need to get back to 1 pi. How much do I need to take away? That would be just 2 pi over 71. Number 3, quadrant 2, meaning I needed to push forward. How much more do I push forward to get to 180? That would be 28 degrees. And then here, how much do I need to push back, because I'm in quadrant 3, to get to 180? That would be 42 degrees.